So that first sheet you picked up today that's green, unlike mine, is to assist you in case multiplying and dividing isn't necessarily your strong suit. So like if I sit here and said, okay, 30, name off every pair of numbers you can multiply to get 30, some of you'd snap them right off, and some of you'd be like, and maybe even go to the calculator. So this sheet that I gave you is to help you with that. It's usable on quizzes and tests. Shh! So you don't think, the only work that it'll be is the one that says day 2 is going to be the homework that we're doing, but I will be referring to that other sheet here in just a moment. So, all right, when we start heading down the road to factoring, we're going to start really basic here today. Basically, I'm not going to be doing some of the things that are mentioned here at the top of this sheet, where you literally would take every single small number that multiplies to the big ones and then take pieces. That takes too long. There's too much going on here. Sort of like I said this, it's almost like we're learning a foreign language. We're not going to do the foreign language way of doing things. So here's what we're going to do instead. For the big number in front, so like if I had these two values, 16 and 72, I would want to find the largest number that will divide into the numbers listed. So for instance, if I was using the example from up here, 16 and 72, here's what I would do. I would go through and I'd say, okay, let's see here. 16 and 72. I am going to be attempting in this chart, if, and again, multiplying and dividing isn't your thing, to find some row or column that have 16 and 72 both in them. Yep, I was going to say, now some of you may just want to kind of start moving along here, and you can scan pretty quickly. I know how quick some of you are on things. And you start going, okay, well, there's 16, no, 72. And you start going along. You're like, ooh, there's 72. Yeah, no, 16. And then you get to here, and you're like, ooh, 16 and 72. 8's the biggest number that goes into both of them. That's how I can use the chart if I need it. So for instance here, I'd be like, okay, so 8's my biggest number that divides into both of them. And you could just try guessing checking on a calculator. That'll work okay, but that might take a little while. So then number 2 is for the variables. Okay. We're going to take the smallest exponent from each variable as long as the variable is in every term. So for instance, again, if I came back up here, I have x's in both, I have y's in both, I have z's in both. So I'm going to have all 3 of those variables. But I just want to take the smallest exponent each time. So I look here and I have, okay, I have x and x, and we know when I don't see an exponent, I assume it's a 1. So I'd have 8x, or if I wanted to put 8x to the first, I could. When I get to the y's, again, smallest. One of them has a 1, one of them has a 2. Yep, got to take the smaller one. So y to the 1. Exactly. And when I get to the last one, I have z to the second and z to the third. I take the smaller one. Z to the second. And that would be what's called my greatest common factor, or my GCF. That's basically what we're doing on any of these today. So, and that's all we're going to be doing. It's not like I'm going to add 3 more parts or something. So like on the first one, I gave the answer, okay? Because if you stop for a minute, and again, whether you're working off the top of your head or with the chart, okay, if I was using the chart on this one, first thing I do is look at the numbers, 49 and 63, and I want to find a row or column that has both of those in it. So I kind of start working through, and I'd like to find the greatest, the biggest one. So I'm like 49 and 63. Okay, when I get to, and I can do it in a row or column. So if I get to 7, I'm like, ooh, there's 14. Ooh, there's 63. Okay, they're both in this column. So I just use the number that's at the start of the row. So I'm like, okay, 7. And then I look here, I've got x, or x squared. 1 is the smaller one of the two. I use that. I'm done. Okay? It's as straightforward as that. So if I get to number 2, yep, I've got 4 and I've got 28. Perfect. I could, with 4 and 28, look on my chart. Okay, there's a 4. Oh, there's a 28. Okay, it's 4. It's whatever that number is that's bolded and underlined at the start of my row or column. So 4. I have A's in both, but this one's got the smaller exponent. So A, or I can put A to the first. That's fine.
So you just put in the smaller exponent?
The smaller exponent every time. And they both have a B, but it's 1 each time. So I'm good. Now, will that happen every time with my variables? No. Sometimes I may get something else that's coming along. Now, here's the other little caveat to things, the other little problem. You may run into a number occasionally that you don't find all of them. You're like, well, what do you mean? So, for instance, in my number 3, I have 96, I have 12, and I have 8. So I start looking, and I'm like, okay, 8, 96, and 12. So, well, here's 8. Okay, there's 96, but I don't see 12 anywhere. Like, crap. Oh, let's see. Here's 8. Here's 12, but there's no 96. But here's what you want to do there in that case. So I noticed, I see 8 and 12, but this doesn't go up any further. It goes to 60 and it stops. So if I find the first two numbers, let's test a theory out here. So we saw that 8 and 12 worked here. Let's take 96 and divide it by that number in the front and see if it goes in evenly. Because my chart can't go forever. Ooh, it does. So I see that 4 goes into 96. It goes in to my other two numbers. So in this case, my number is 4. So sometimes I may have to play with the calculator a little bit. If you only find 2 out of the 3 numbers, see if you can divide the third number in. But then the variables get a little interesting. And because that's interesting, why am I saying no variables? That's kind of silly now, isn't it? Because if I look, I see x here. Do any of my other... Oh, I know why I just said that. Do all 3 of my terms have an x? No. Now y, I'm getting closer. Do all 3 of my terms have a y? No. All of my terms, so I shouldn't have crossed this out, bad me. My variables have to be in every single term that's there, whether there's 2, 3, however many terms. If it's not in all of them, I can't use the variable. Okay? Sometimes it may work for one and it may not work for another. For instance, what if I get up here and I go, okay, so 12 and 18. Okay, 6 works. Right, because I look through it, I'm like, okay, I see an A in both, and it's just A. There's no exponent, so I'll just put the A. If you want to put A to the first, you can. But is B in both of them? No. C in both of them? Nope. I'm done. So again, I'm going to skip over 5 for right now because, well, that one, I've already got an answer down here, just in case I had someone pick one of these up and they didn't hear me talking it out. Okay, so let's look at number 6. 2, 12, and 18. Okay, 2. It'll never be bigger than your smallest number is. So it couldn't be bigger than 2 because 2 can divide into itself. So I got a 2. Look at your variables. I got m squared, I have m, and I have m. What's the smallest exponent? 1, or just m. And again, I can put m. Okay, yep. And then I see that there's a p term in every one. And again, I take the smallest exponent. Since I see some of them don't have an exponent at all, it means it's just going to be my p. You can put, yeah, if you want to put 1s on those, you absolutely can. But we assume there's a 1 there. So if for some reason that doesn't work, then I just don't worry about it. So now let's start getting into something a little bit bigger. So number 7. Oh, 12, 32, and 60. Okay, 4. And again, whether you're playing with the calculator, you're doing it in your head, 12, there's a 12, there's a 32, there's a 60. Okay, in this case, I found all 3 of them. If I'd only found 12 and 32, and let's say the next number was 68, I'd try to divide the 68 by 4. But if I can find the 2 smaller ones, that's a pretty good clue. So, okay, so I got 4. Now, variables. Do all of them have an x?
Yep.
Yep. And since I see an x that doesn't have an exponent, that's the one I'm going to use because it's x or x to the first, and that's my only one. Do all of my terms have a y? No, can't use it. Do all my terms have a z? No, can't use it. I'm done. Okay, so we've seen anything from just a number to a number and a variable to a number and 2 variables. We're never quite sure.
So if like if there's more than one like x or y or z, that's what the variable is. Let's say x, just like 12x is root 2 and 32x, which is it's just x because there's 2x.
Yeah, whenever I'm doing this, I take whichever one's got the smallest exponent. So like here with x's, I got x to the second, but this last one's only x or x to the first. And I can only take the smallest one each time. So that's kind of my judgment. Now 8, I'm throwing a curveball at you. Remember, this is called the greatest common factor. So I got to find the biggest number that goes into 18 and 36. Any ideas?
9.
Okay, let's try out 9 and see what happens here. Oh, look out, we're going up again already. Okay, some of you may say, you start looking on your chart and you get to 9 and you're like, hey, 9, I got both of these. This is cool. And you use 9. Now, here's what I'm going to tell you. And this is going to be tricky to see this first day. It's actually bigger than 9. It's actually a number that's not on your chart. Now, some of you are going to say, well, is it wrong if I do 9? Not exactly. It's something that you'll see a little bit more. Now, if you wrote the 9, I'm not going to worry about it. But it is 18, because 18 will divide into itself, of course. I always check to see, a number can divide into itself. But if I do that, I always like to check and see, can I take my other number and divide it by that first number? And if it goes in evenly, and it does, it'd be 18. So like for a quiz and you put 9, it'd probably be a halfer, but for most of you, once you see the next step to this process early next week, I think that'll click for you. So again, for now, if you're just going straight off the chart and you get one that's a little small, that's okay. So what about my variables, though? No, they don't cancel. But here, since the smallest exponent I see is 3, since they both have 3, I'm going to use a to the third. Okay, because that's the smallest one they have. So if that's true, what's going to happen with my exponent on b then? B to the second. Because again, that's the smallest exponent I see. So sometimes you'll have something other than 1. That can happen. And then we got the big kahuna at the end. Oh my. Any of our columns got all 3 numbers in it? $21, $28, and $84. Let's see. It would. 21, 28, 84. Got all 3. Don't even have to think about it. So 7. Yep. When you start looking at your variables, okay, I've got an a in each one. Smallest one, though, is 3. So a to the third. Then I look at my b's. Yep, we got a b in every one. Smallest one in b is 2. Is f? What's that? Perfect. And we leave the f out because there isn't one in the middle. We're good. So that's kind of what we're up against.
What does that be saying? That
B to the second. So now, I'm also going to start blending in here And I'm going to come back up to the top in a minute. But we're going to start blending some review things in because with what we're doing, we're going to get a little stretch for time at the end on some final review. So I'm going to kind of start blending some of it in so we've got some experience back with it. So we're going to multiply these things out. Now again, you'll notice over here, oh yeah, it's that box thing. And some of you did FOIL with the little lines that made the smiley face guy. That's okay too. We'll look at one that way. But this is the one I specifically want to touch on. Okay, a minus 4 squared does not mean I can just distribute the squared and be done. What this means is I have 2 of what's inside those parentheses. So I have 2 a minus 4s.
So you just put them together.
So what we're going to do, if you're a fan of the box, you could make your box, put an a minus 4 along each side of it, and then exactly, and then just fill in the boxes. We're multiplying to fill in the boxes. Negative 4 times a is negative 4a. Negative 4 times a is still negative 4a. And negative times negative is positive. Okay. Let's look. I'll do FOIL again too here in just a minute. Yep. Exactly. I multiply to fill the box, and then once the box is full, I combine any terms that are alike. So here I got to be careful. Negative 4 and negative 4 is negative 8. I don't mess with the exponents anymore. Okay? No, because I'm adding them. It's like if I owe somebody $4 and I borrow 4 more, now I owe them 8. And so this is what my FOILed out answer would be. Now, if you're not a fan of the box, and not everybody is, here's your other option. Now you're going to get the same answer at the end. Some of you just like looking at it and going, okay, here's my first terms, a times a, okay, so that's a squared. And then a times negative 4 is negative 4a. And negative 4 times a is negative 4a. And negative 4 times negative 4 is 16. And again, I know I've covered everything when my little smiley faced guy shows up. Because now I can just say, okay, those are the terms that are like terms. So those are the only ones I can put together. And I get the same answer. Whichever way you're more comfortable with is the way you should do it. If you like foiling, FOIL. If you like boxing because you like to visually see what's going on, that's fine. Now, again, 17, I'll do both one more time just so you can see. So if I go boxing, I'll do it a little lower here. So we got plenty of room. It doesn't matter which set of parentheses goes along which side. If I put plus 7 here and minus 7 here, I'm going to get the same answer at the end. But again, when I'm filling it in, d times d, d to the second, plus 7d, a negative 7d, and a negative 49. This time, though, my first term will always be up to the right, but what happens when I combine my like terms? 7 minus 7, they're gone, and I just get minus 49. And the exact same thing will happen if I said I'm going to do d times d is d squared minus 7d plus 7d minus 49. Positive and negative 7d still cancels, and I still get the same answer. So again, don't let that stuff get to you. Multiply to fill the box. Okay, I'm just going to, oh, and I even put it here. Multiply to fill the box, then add like terms. Okay? And then the only thing left down here at the bottom is just a review of the distributive property, which is going to come in handy for our next step once we're doing these factors. I'm multiplying whatever's outside the box or outside the parentheses times what's in. 2 times 4 is 8. Keep my x. 2 times -7 is -14. Okay, I'm done. Or if there's a variable out there, right, x times x is x squared, and I have the 3 with it. But I've got to remember, it goes to both terms, not just the first one. 3 times 9 is 27, and I take the x along, and I'm done. So it's just the whole idea of getting used to, well, some of the review, but also just biggest number that goes in on these, and then the variable they have in common. I want to do one more of these up top. How's about... How's about 14 up top here? Let's make sure, kind of now we did the review, that we get back on track here. So 6, 18, and 42. The biggest number that goes into all three. 6. There's 6. There's 18. There's 42. I got them all. So 6. Do we have A's in all of them? We do. We take the smallest one we see, but they all don't have B's, so that's as far as I can go. Okay? What's that? It's not bad. So
the number that you're going to get that,
okay. So again, work on the secondary sheet that you picked up that I, of course, oh, I did bring myself one. Okay? You're just finding the greatest common factor on these. Okay? Actually, let's chat about that since we got up here. Sometimes you may find that you don't find a number in the list that works for all of them. You're like, well, I can find one that works for 2 and 18. I can find one that works for 9 and 18, but nothing works for all three. When that happens, you may get 1 as your greatest common factor. 1 will divide into all of those, but it's the only number that does. And then again, I go back and just look at what I have left. X is my smallest x, or I can put x to the first. And when I look at my y's, 1, 3, or 2, 1's the smallest one. So it is possible occasionally that you'll find no number that works for all of them. It doesn't happen very often. Maybe, I don't know, maybe one other time on the sheet. Okay. But that's, again, we'll be up to this on Monday as well. So that's